For this assignment, I'm going to have you practice some of your applications with quadratic equations. So we've done some of these before, but I'm going to help you set them up so that you have the correct equations, and then I'll ask you to solve them. Remember, when you're solving, we've learned 4 methods: graphing, factoring, quadratic formula, completing the square. It is your choice of what method you like best to solve. So for number 1, it's asking us to find 2 real numbers such that the sum is 4 and their product is negative 117. So we're going to try to avoid using 2 variables. We're just going to use 1 variable. Okay, so for step 1, you can draw pictures, you can underline key important information, whatever you need to do. But we know the sum is 4 and the product is negative 117. So to define my variables, I know that my first integer is one thing I'm looking for, and I'm going to call that x. My second integer is going to be, the sum is 4, so that'll be 4 minus x. Okay? Now that I have those 2 defined variables, I can now write my equation. And the equation is that we know their product. So the first integer times the second integer has to give me the product of negative 117. What you need to now do is go ahead and distribute that. 4x minus x squared equals negative 117. And now rearrange that so that it equals 0 and solve. Next, we will complete number 2. So for this one, it says we have a rectangular penguin pond at the Bay Park Zoo, and it's 12 meters long by 8 meters wide. The zoo wants to double the area by increasing in the length and the width by the same amount. Okay, so in this scenario, I'm going to draw a picture. For my original problem, we have a 12 by 8 little pond. Now what we want to do is we want to double that area by increasing the length and the width. So I'm going to use a different color, and I'm just increasing it on each side. So I'm going to increase the length and the width. What that means is that I'm adding x amount to both the width and the length. So when I define my variable, x is the amount the width and length is increased. So now we need to figure out an equation. Well, it says that when I do that, when I add that x, I've doubled the area. So what's the area of the original? The original was 12 by 8. So that means the original had an area of 96. So I'm using blue to show that that was 96. The new area has to be double that. So what is double of 96? Double of 96 is just 96 times 2, of course, which gives you 192. That means that the new area has to equal 192. Well, how do I represent the new area? That new area is going to have a width of 8 plus x, a length of 12 plus x, and we know length times width has to equal area. So at that point, you should FOIL it out, make your equation equal 0, and then choose whichever method you like to solve. Let's look at number 3. Number 3 says, one leg of a right triangle is 4 centimeters longer than twice the other. Find the length of the leg if the hypotenuse is 26 centimeters long. Okay, so for this problem, what we need to remember is our rules about right triangles. So remember, with right triangles, we have that a squared plus b squared equals c squared, our Pythagorean theorem. Let's define our variables. So they're telling us that leg number 1 is 4 centimeters longer than the other leg. Okay, so if we have our two legs, we could define leg 1 as x, and leg 2 is 4 centimeters longer than twice the other, so that's 2x plus 4. We know the hypotenuse is 26. Remember, our legs are the A and the B, and the hypotenuse is C. So now my equation will simply be leg squared plus second leg squared, make sure it's in parentheses, equals hypotenuse squared. So again, I will leave this up to you to solve. Make sure to FOIL, combine our like terms, and make the equation equal 0 to then use factoring, completing the square or quadratic formula. Okay, number 4, I'm going to leave for you to do on your own. Just remember, the general formula for our height is h of t equals, in this case, we are talking meters. So that'll be negative 4.9 t squared plus the initial velocity times t plus the initial height. Okay, so fill in the rest of the blanks for your equation and then solve for parts A and parts B.